Hello, welcome to the Finite channel and welcome to the static routing. You know that there are so many different ways to dynamically route a packet that you might wonder why anybody or an administrator would take the time to manually configure a static route. Let's take an analogy. It's like we do the hand washing of our clothes when you have a perfectly good washing machine. And we know that some of the clothing items cannot go into the washing machine because some items benefit from being washed by hand. So this is similar to the networking, which means that there are many situations where manually configured a static route is your best option. And there are different kinds of static routes, and each is perfect for solving or avoiding a specific type of network problem. Many networks use both dynamic and static routing, so network administrators need to know how to configure, verify, and troubleshoot static routes. So in this material, we want to become a network administrators and we want to improve our existing network administrator skill. And we will use these skills frequently. And what we will learn in this material is that we will describe the common syntax for the static routes. We will configure IPv4 and IPv6 static routes. We will configure IPv4 and IPv6 default static routes. We will configure a floating static route to provide a backup connection. And then we will configure IPv4, IPv static host routes that direct traffic to a specific host. So let's start with the first one where we will configure the static route by showing the common syntax for the static routes. Static routes are commonly implemented on a network, and this is true even when there is a dynamic routing protocol configured. For instance, an organization could configure a default static route to the service provider and advertise this route to other corporate routers using the dynamic routing protocol. Static routes can be configured for IPv4 and IPv6 networks. Both protocols support this type of static route as a standard static route, default static routes, floating static route, and summary static route. And these are configured by using the IP route and IPv6 route global configuration command. So let's start step by step. When configuring a static route, the next hop can be identified by an IP address, exit interface, or both. How the destination is specified creates one of those types of static route. We have the next hop route where only the next hop IP address is specified. We have directly connected static route where only the router exit interface is specified. And we have the fully specified static route where the next hop IP address and the exit interface are both specified during the configuration. IPv4 static routes are configured using this configuration command on the global configuration. As you can see, we are in the configuration mode, and by using the IP route, we start configure the static route. It's followed by the network address, the subnet mask address, and then it may be followed with the IP address of the next hop, the IP address of the exit interface. So either IP address, exit interface, or the IP address and the exit interface parameters can be configured as we explained a slide before about the options of the next hop. So let's explain each of those. The parameters that are followed after the IP route stand for the network address is the destination IPv4 network address of the remote network to add to the routing table. The subnet mask identifies the subnet mask of the remote network, and this subnet mask can be modified to summarize a group of networks and create a summary static route. And then the IP address identifies the next hop router IPv4 address, typically is used with the broadcast networks, and could create a recursive static route where the router performs an additional lookup to find the exit interface. And as for the exit interface, it identifies the exit interface to forward the packets. It creates a directly connected static route and typically is used in a point-to-point configuration. And if we have the exit interface IP address, create a fully specified static route because it specifies the exit interface and the next hop IPv4 address. And the distance is an optional command that can be used to assign an administrative distance value between 1 and 255. Typically is used to configure a floating static route by setting an administrative distance that is higher than a dynamically learned route. And as for the IPv6 static route command, it's as it is shown here with global configuration mode followed by IPv6 route, and then there are the parameters. And as in the first slide, the description for each of those parameters is that IPv6 prefix identifies the destination IPv6 network address of the remote network to be added to the routing table, and the prefix length identifies the prefix length of the remote network. IPv6 address identifies the next hop router IPv6 address, typically is used with broadcast networks and could create a recursive static route where the router performs an additional lookup to find the exit interface, same as in IPv4 network. The same description is even for the exit interface, similar to IPv4, where it identifies the exit interface to forward the packets, create directly connected static route, and typically is used in point-to-point configuration. And if we use exit interface followed with the IPv6 address, we create a fully specified static route because it specifies the exit interface and the next hop IPv6 address. And as for the distance, same is optional command that can be used to assign an administrative distance value between 1 and 255. And it typically is used to configure a floating static route by setting an administrative distance that is higher than a dynamically learned route. And for showing the commands in a network, we will use a dual stack topology, where a dual stack topology is usually a topology for both network, IPv4 and IPv6 network, as it is shown here in this figure, where we have router 1, 2, and router 3. Router 1 and router 3 are both connected with singular LAN, and router 2 is connected with a LAN, and when each of those routers communicate with router 2 communicates with router 1 and router 3, and we are trying to configure the static route to show how a router adds a static route in his routing table. So let's start with IPv4 that starts creating the routing table. So we will start with router 1. So let's use show IP route and let's see what is in the router 1 IPv4 routing table. We will use this command even for router 2 and router 3 to see the IPv4 routing table. And then we can see if router 1 can ping router 2. And we can see that the router 1 cannot ping router 3. Why is the question. So let's see. By using the show IP route, or this begin with gateway, we are able to see the directed connected network at the router 1. And as we can see, is the network 172.16.2.0 that is directly connected through the serial 010. And we have the network 172.16.3.0/24 connected with Giga Ethernet 000. And we have the local network, which here it describes even the IP address of the interface that is connected in that line. Same, we can see that router 2 shows only the directed connected network to this router. And again, the router 3 is his IPv4 routing table. And as you can see here, it is showing only directly connected network. And we know that the directly connected network are added at the routing table as soon as we configure the interface of the router. As soon as this interface is configured and with an IP address and the interface is active, it automatically is added to the routing table. And if we try to ping the router 2 from router 1 by using the command ping 172.16.2.2, which is the IP address of the serial 010, it's the interface that is connected with router 1 from router 2. And as we can see, they are able to ping each other. But if we use the ping command to see if router 1 is able to communicate with router 3 with the interface serial 011, which is the IP address as 192.168.2.1. You can see that from the previous slide. You can see that they cannot communicate. Why? Because router 1 knows his directed network and he can communicate with the devices in each of those directed network. But for router 1, router 3, it's a remote network and he can communicate with that because there is not a route in the routing table that show how to reach this router 3. So to do that, we have to configure a static route. Same we can do even for the IPv starting routing table. Similar to the IPv4, we use the show IPv6 route. And here again, we can see that are only directly connected network for each of those routes, router 1, router 2, and router 3. And again, here we see that router 1 is able to communicate the router 2 because router 1 and router 2 are in directly connected network for router 1 because router 1 knows the network that is connected from the interface Giga 00 and the network that is connected with the interface is serial 010 of router 1. So he knows both of the network, and he knows that router 2 can be reached at the network 172.16.2.0 through this network. And as for the router 3, as we said, there is not a route in his routing table that shows how to reach this router in the network. And here again, even for IPv route, we will configure the IP static route. The command to configure standard static route varies slightly between IPv4 and IPv6. Here we will show how to configure standard next hop directly connected and full specified static route for both IPv4 and IPv6. In a next hop static route, only the next hop IP address is specified in the configuration. The exit interface is derived from the next hop. For example, the 3 next hop IP static routes are configured on router 1 using the IP address of the next hop for the router 2. So here it is showing the command to configure router 1 with the IPv4 static route to the 3 remote network as follows. So router 1, so it's explained like this. Router 1, by using the IP route, is able to reach 172.16.1.0 with the subnet mask 255.255.255.0, which is the network connected at the router 1 through the interface Giga 000. And as we said, we are showing the next hop. And the next hop to reach this network is the IP address of 172.16.2.2, which is the IP address of the next hop, which is router 2, the IP address of serial 010. Again, router 1. So by using the IP route, we can explain like this. He can reach the network 192.168.1.0, which is the network between router 2 and router 3, with the subnet mask 255.255.255.0 through the next hop, which is the IP address of 172.16.2.2 and is the IP address of the serial 010 of the router 2. And the third network, by using the IP route command, we add the 192.168.2.0 with the subnet mask 255.255.255, which is the directly connected network at the router 3 through interface Giga 000. And this network can be reached by the next hop router, which is the IP address of the interface serial 010 of router 2 and is 172.16.2.2. And the routing table for router 1, now that we add the 3 remote IPv4 network, if we use the show IP route, is listed here. And as you can see, here are added 3 static routes that we just configured. And we can identify them by the code S at the routing table. And as you can see, it is shown the network, the subnet mask /24, and is showing the next hop IPv4 address. Similar to this, let's configure the IPv6 NetHop static route. The commands are slightly different, so depending on the dual stack topology that we had, we start configuring at the global configuration by using the IPv6 unicast routing. And then we say IPv6 route, where we add the IP address of the network, followed by the prefix length, which shows the subnet mask of the destination network, and the next hop, which is the IP address of the serial 010 of the router 2. And as you can see, here are listed 3 remote networks. The first one is the network that is directly connected at the router 2 through interface giga00. The second network is the network between router 2 and router 3. And the third network is the network directly connected at the router 3 through interface giga000. And again, if we use the show IPv6 route here now for the router 1, we will be able to see the 3 remote IPv6 network that we just added by the code C at the routing table. Now, again, based on the dual stack topology, let's see IPv4 directly connected static route. Because when we configure a static route, another option is to use the exit interface to specify the next hop router. So based on the dual stack topology, we have the option to configure directly connected IPv4 static routes that are configured in the router 1. And as you can see, for router 1, we can say that IP route, and we can reach the 172.16.1.0, which is the network directly connected to router 2 through giga00, with a subnet mask 255.255.45.0. We can reach it via interface serial 010 at the router 1, which is the interface that we have to forward the packet to reach this network. Again, the next line says that IP route, we are configuring static route for reaching the network 192.168.1.0 with the subnet mask 255.255.255.0, which is the network between router 2 and router 3. And we can reach this network through the interface serial 010 of router 1, which is the interface that we have to forward the packets to reach this network. And for the last one, we say that we are configuring a static route by using the IP route command to reach the network 192.168.2.0 with the subnet mask 255.255.255.0 using the interface serial 010 of router 1, which is the interface we have to forward the packets. And here, if we use the show IP route, we are able to see the static routes that are configured here in this network by using the directly connected static route command, where we use the interface that we need to forward the packet. And it looks like for match in this routing table, and we find that all the packets are forwarded from the serial interface 010 of router 1. And usually is generally recommended to use the NetHop address, because the directly connected static route should only be used with point-to-point serial interface, as it is here in the example. Same is even for IPv6 networks, where by using the IPv6 route command followed by the IPv6 address of the network that we want to reach, followed by the prefix length and the interface of the router 1 where we have to forward the packet. And here are shown 3 remote networks that are added to the router 1. And by using the show IPv6 route, we are able to see the 3 static routes that are added to the routing table. Again, even in the IPv6 network, it's recommended to use NetHop address because static routes should only be used with point-to-point serial interface, as it is shown here. And the last option is where we configure a fully specified static route. And we will configure this for both IPv4 and IPv6 network. Again, we will follow the dual stack topology, and the difference between an Ethernet multi-access network and point-to-point serial network is that a point-to-point serial network has only one other device on that network, and the router at the other end of the link. With Ethernet networks, there may be many different devices sharing the same multi-access network, including host and even multiple routers. So it is recommended that when the exit interface in an Ethernet network, that the static route includes a next hop address. So you can also use a fully specified static route that includes both exit and the next hop address. And here we are configuring the router 1. We are adding the 3 remote networks by using the IP route command. And the parameters that are listed here is, so we are here in this topology, which is different from the topology that we had before, slightly different. We have 172.16.1.0 with the subnet mask 255.255.255.0, which is the network that is connected to the router 2 through interface giga00. We are able to reach this network if we forward the packets at the router 1 through the interface giga Ethernet 001, and the next hop router is the router that has the IP address 172.16.2.2, which is the IP address of the router 2 at the interface giga 001. And the next line, we can explain that we are configuring a fully specified static route by using the IP route command, and we can reach the network 192.168.1.0 with the subnet mask 255.255.255.0, which is /24. We can forward the packets to reach this destination at the router 1 through the interface 001, giga Ethernet 001, and the next hop router is the router that has the IP address 172.16.2.2, which is the IP address of the router 2, which is the next hop router through the interface giga 001. And the last line is the IP route. We are configuring such a route to reach the 192.168.2.0 with the subnet mask /24 through the interface giga Ethernet 001. As interface, we have to forward the packets at the router 1. And the next hop router, next hop is the IP address of the interface giga 001 of the router 2, which is 172.16.2.2. And when forwarding packets to the router 2, the exit interface is giga Ethernet 001, and the next hop IPv4 address, as you can see, is 172.16.2.2.2, and here it is shown the output by using the command show IP route at the router 1, and as you can see here, the static route, it's fully specified where we can see the network that we can reach and the subnet mask from which is the next hop router and from which interface we can reach that network at the router 1. as it is listed here. And as for the IPv6 fully specified static route, both the exit interface and the next hop IPv6 address are specified. There is a situation in IPv6 when a fully specified static route must be used. And if the IPv6 static route uses an IPv6 linked local address as the next hop address, you have to use a fully specified static route. Here is a figure where it shows an example of fully specified IPv6 static route by using an IPv6 linked local address as the next hop address. And here is the command that we use. So we are configuring static route by using the IPv6 route to reach the destination to 001 db8 ACAD1/26 by using the next hop IPv6 address, which is an IPv6 linked local address. And here in this example, a fully specified static route is configured using the link local address of router 2 and the next hop address, which is in the next line. As you can see, it is specified even the address of router 1, which is where we forward the packet, which is the serial 010 interface. The reason a fully specified static route must be used is because IPv6 linked local addresses are not contained in the IPv6 routing table, and linked local addresses are only unique on a given link or a network. The next hop link address may be a valid address on multiple networks connected to the router. Therefore, it is necessary that the exit interface to be included during configuration. And here, if we use the show IPv6 route static, we are only for this particular network. That's why we use the section begin of the address of the network. We can see that we have a static route to reach this network through next hop IPv6 address, which is a link local address of the router 2 at the interface serial 010, and is the forwarded packet interface of router 1 as serial 010. So, as in every configuration, we have to verify our configuration that we did in the network, and in this case we did in the router 1, which means that we have to verify the static route that we configured. Along with the show IP route, show IPv6 route, ping address route, there are useful commands to verify the static routes, including the show IP route static, show IP route the network section, followed by the network, and show running config the section IP address. And if we replace the IP with IPv6, we are able to use this command for the IPv6 network. So let's refer to this figure and review the networks that are configured at the router 1. So if we use the show IP route static, we can the gateway, we are able to see all the static routes that we configured at the router 1. And here, as you can see, they are configured using the next hop address. And if we use the command show IP route followed by the specific IPv4 network, we are able to see only the network, a particular specified network in the routing table. And by using the command show running config with the section IP route, we are filtering the running config configuration for only IPv static routes. And if we use same to display IPv6 route, we use the command show IPv6 static route static, and we are able to see all the static routes that are configured in the router one. And if we want to display a specific IPv6 network, we use the command show IPv6 followed by the network address of the IPv6 network that we want to show. And if we use the running config and we filter the running configuration for only IPv6 static route, we are able to see the IP static routes configured in the router one. Here in this syntax chapter, we will configure the static route for the router 2 and router 3 for both network, IPv4 and IPv6 network. And here, first, we will start configuring the router 2, where we say that we will configure the next hop static route on router 2 to reach the network 192.168.2.0/24, which is the network directly connected to the router 3 through the interface giga00, by using the next hop address, which is the IP address 192.168.1.1, and is the next hop, which is the IP address of the router 3 in interface serial 011. So as you can see, we use the command IP route 192.168.2.0 followed by the subnet mask of the network, which is the /24 255.255.255.0, and the next hop IP address, which is 192.168.1.1, is the IP address of the router 3 as the next hop through the interface serial 011. And then what we will do, we will configure a static route, a fully specified static route router 2 to reach the 172.116.3.0/24 by using the exit interface and next hop pair. So to reach the network 172.16.3.0/24, which is the LAN that is connected at the router 1 through the interface giga00, we say the pair is the next hop, which is the hop of router 1 at the interface giga001, which is the IP address is 172.16.2.1, and the exit interface is the interface giga001 at the router 2. And that's why the command is IP route 172.16.3.0 with followed by subnet mask, the exit interface where we have to forward the packet at the router 2 to reach this network, and this is the next hop, which is the IP address of giga001 as 172.16.2.1. This is by adding the two networks, two reboot network at the router 2, and then we will go and configure the IPv6 static route for the IPv6 network, and in router 2 to reach the network that is connected directly at the router 3 by using the next hop address, which will be the IP address of the serial 011 on the router 3. And we use the IPv6 route followed by the destination IP address, which is the IP address of the network connected to the router 3 as a remote network for router 2, followed by the prefix length for this network, and followed by the next hop IP address, which is the IP address of the serial 011. And then we configure a fully specified IPv6 route on router 2 to reach the network that is connected at the router 1, which is the LAN network connected through the interface giga00. And as we said, the fully specified, which means that we have to use the pair exit interface and next hop, which the exit interface for the router 2 is giga001, and the next hop to reach the network the LAN network that is connected to the router, directly connected to the router 1 through interface giga00 is the link local address of the interface giga001 on router 1. So after we exit from the global configuration mode, what we will do, we will display the IPv6 route by using the command show IP static route. So IP route static, sorry. And as you can see, there are two networks that are listed. One is fully specified, which is the first static route, and the second one is. So now we use even the show IPv6 route static for showing the IPv6 static route that are configured. Now we are in the router 3 where we'll go through the same steps. First, we will configure the network. We will configure directly connect the IPv6 static route on the router 3 to reach the LAN network that is connected in router 1 at the interface giga00 by using the exit interface here in this. So we say IP route, the destination 172.16.3.0 with the subnet followed by the subnet mask, and we can reach this network by using the interface serial 011 at the router 3 to forward the packets to reach this remote network. And then we will configure directly connect the IPv4 static route on router 3 to reach the 172.16.1.0/24, which is the LAN network connected at the router 2 through the interface giga00 by using the exit interface of router 3, where we have to forward the package, which is serial 011. And as you can see, the command is IP route 172.16.1.0 followed by the subnet mask and the exit interface serial 011, which is the exit interface of router 3. Now we have to configure directly connect the IPv static route on router 3 to reach the network between router 1 and router 2, which is the remote network for router 3, by using the exit interface again. And so the command is IP route 172.16.1.0 followed by the subnet mask and followed by the exit interface. Sorry. And now we are configuring the IPv6 route, where we configure directly IPv6 route by using the exit interface for all three remote networks, same as the IPv4 network, just we have to change the command IP route with IPv6 route, and then we will use the destination network that we want to reach and the exit interface. And after that, we have to exit from the global configuration to do the verification about the commands that the network that we created by using the show IP route static for the IPv4 network, where we can see that we have the network that are listed in the routing table as a static network, and there are networks that are configured by configure the static route using the exit interface. So with this syntax checker, we are ending all the topics that we had for the part 1 of the IP static routing. And in the next material, we will configure the IP default static routes, floating static routes, and we'll configure even static host routes. So see you to the next session, and don't forget to subscribe to the Finetlink channel if you are new to this channel, and share it with your friends if you like this material. See you soon.